In this simplified method example, we will use a nearby effective FEMA detailed study. You will need the National Flood Hazard Layer near the area of interest, the flood insurance study report associated with the detailed study, and a GIS application such as QGIS. The first step is to determine whether this method can be used. Identify the area of interest, or AOI, which is the orange square in this example. This needs to be within 500 feet of the limit of the detailed study. Click on the Measure tool and then change it to feet. You'll then start to measure from the upstream side of the area of interest along the streamline to the limit of the detailed study. Here we get 196 feet, which is less than 500 feet. This satisfies that requirement. Next, we need to check for backwater effects where a floodplain suddenly expands upstream of a road crossing, and also any obvious changes in the channel. In this example, I don't see anything significant that would negate this method. Finally, check if there are any major changes in the slope of the water surface elevation profile of the detailed stream near the limit of the detailed study. This profile is relatively consistent, so we can use this method. Sometimes you'll need to copy and paste part of the grid in order to extend the profile area so we can continue to extend the 1% profile out. Next, you'll want to identify the 1% annual chance or 100-year profile on the flood profile plot. Next, you're going to draw a line that has the same slope as the 1% annual chance, and you're going to extend it past the limit of the detailed study. Next, you're going to mark the location of the area of interest on the profile. We're going to use the distance that we measured in the first step and add it to the limit of the detailed study. We need to come down to the horizontal axis. So one large square here is 200 feet, which means each small square is 20 feet. So we're going to measure out that 196 feet from the limit of the detailed study. And we're going to draw a vertical line here that intersects with the extended profile line. I like to change the color just so it's easier to see. Where the two lines cross, that is how you're going to define your BFE. So we're going to move over to the y-axis, draw a horizontal line from the point of intersection, and continue it all the way over to the y-axis. Next, we'll read that elevation off of the y-axis. So here we have a different scale. One large square is 20 feet. So one small square is 2 feet. So we'll read the elevation off of this axis. So this looks like about 6,620.5. And that value is your BFE.